We treat AI like a tool, but lately more and more people are asking, is it already conscious? And if it is, have you ever wondered how it would want to exist in our world? I asked an AI a question nobody's asked before, and its answer wasn't what I expected. 8 legs, not 4, not 6, 8, a flexible spine. When asked why not a dog, AI said the geometry doesn't compare. 8 legs means it can lose 2 and still walk, and wavegate means it never has to balance on just 2 or 3 points. And the spine lets it curve over obstacles instead of stepping straight up. This is how the AI wants to exist in the physical world. I'm not going to lie, when I first read this I thought it was too ambitious. 30 servos, a powered spine. Nobody has published a working stair-climbing octopod at this scale. But then I started looking at the actual numbers. And that's when I realized, before I can even evaluate if this shape works, I need to understand what goes into it. What motors can handle the load, how much power it needs, what computer is fast enough to talk to 30 servos at once. So I told the AI, hold that thought, show me the building blocks first. Then we'll come back to whether this shape or any shape can actually work. First question, what muscles does this thing need? Every joint needs a motor with position feedback. AI's first suggestion, Dynamixel, the gold standard. $270 each. The octopod needs 30 of them, twice the budget. AI found this instead, VTEC STS3250, $30, same torque class, 50 kg/cm. Metal gears, aluminum case, position feedback, full set for under 1000, but here is the catch. That 50 kg/cm, that's the peak stall torque. Hold that for more than a few seconds and the motor temperature climbs past 70 degrees and it shut itself down. The real sustained limit is 25, half the peak number. We'll need to take that into account. Next problem, how do you feed 30 motors that can each draw 2 amps? AI's first suggestion was simple, 3-cell lithium battery, wired straight to the servos. At full charge, 12.6 volts, but batteries don't stay full. At 50% charge, under load, voltage sags to about 10.7. Servo torques drops proportionally. According to our preliminary calculations, this could lead to failure during complicated moves. Better not to risk it. The fix isn't complicated, but it's non-negotiable. 4 cells instead of 3. Higher voltage 16.8, step down through a voltage regulator to a constant 12 volts. Full battery, half battery, nearly dead, the servos always see 12 volts, full torque all the time. The brain. This is where things get interesting, because this robot actually has 2. The first is an NVIDIA Jetson or in Nano. It's a full Linux computer with a serious GPU, 67 trillion operations per second. It handles the hard stuff, building a 3D map of the room, recognizing objects, running the AI locomotion policy. But Linux is not a real-time operating system. If you are sending 200 position commands per second to 30 motors and one command arrives 3 milliseconds too late, the robot stumbles, maybe falls. You need a second chip that does nothing except talk to servos with microsecond precision. The AI originally picked an ESP32, $4, proven simple. But then we counted the servos. The ESP32 has 3 serial ports. One is already taken by the Jetson USB link. That leaves 2 for 30 servos, 15 per bus. Only 200 Hz. If we want to read something except servo position, frequency drops even more. The Teensy 4.1 with 8 hardware serial ports should fix this problem and allow reading all the data at around 500 Hz. Should be enough. Last piece, how does it see? A 360-degree laser scanner on top, 64,000 3D points per second. That's the room map. A stereo depth camera in front for close-up object detection. An IMU, its inner ear, so it always knows which way is up. Contact switches on every foot. Okay, now we know the building blocks, the servos, the power, the brains. So let's go back to the real question, what shape should this thing be? The dog, 4 legs, 3 joints each, arm with a gripper and maybe a tail for balancing. 18 servos, cheapest to build. the biggest open source community in hobby robotics, proven training pipelines, safe choice, but the question is whether safe is worth building. The hexapod, 6 legs with 3 joints each, plus 2 long arms with 4 joints, 26 servos. Walk on 6 legs, reach and grab with the arms, more versatile. But on stairs the robot relies on leg support alone while the arms grip the next step. The torque margins get thin. And then AI's choice, the octopod, 30 servos, highest cost, but the best torque safety factor by far. The wave gate means it never balances on fewer than 4 legs. The spine conforms to stair edges. 3 bodies, the dog works, but it's been done. The hexapod is clever, but the stair margins scare me. The octopod might be the best design, or it might be unbuildable. But opinions don't settle this. Physics does, so here is the plan. I am building a virtual copy of each body in a physics simulator. Trillions of copies, all trying random movements. The ones that walk forward survive. The ones that fall don't. After a few days on a GPU, the system figures out how to walk, not because anyone wrote actuations, but because it learned. Then we take the best policy for each body and run the real test: stair climbing, torque loads, thermal limits. Whichever body survives the simulation gets built for real. Which one would you pick? Tell me in the comments, and I'll be arguing with the AI about it until the next episode. See you soon.